This is part 2 of the 6.04 mole mass relationship lesson. So we just finished going over how to do the NaCl. And so we took the fact that there was one sodium atom that weighed 23 AMU plus one chlorine atom that was 35.4 AMU, and we get our total of 58.4 grams per mole. All right, so let's go ahead and try another one. So now we have Cl2. So I'm going to say it again, CaCl2. So see if you can figure that one out on your own. Hit the pause button. And there's one calcium, two chlorines. So we take 40 for the one calcium plus 35.4 for the chlorine, but we have to times that by 2, and that gives us a total of 111 grams per mole. All right, now we're going to go ahead and do our next example. So if you want to cover up the right-hand side of the screen, and it's going to be for calculate the molar mass of calcium chloride dihydrate. So that is a very long name, but we can look at the abbreviation, which is CaCl2, and the fact that there are two water molecules. So this molecule has water incorporated into its crystal, so that must be added on. So now we need to go through and say, how much of everything do we have? How many calciums do I have? How many chlorines do I have? So I had one calcium and I had two chlorines. How many waters do I have? I have 2, which means I have how many hydrogens? 2 times 2 is 4. How many oxygens? Distribute this 2, which is the coefficient, and I have 2 oxygens. So go ahead, hit the pause button, plug in your final answer, and you get 40 times 1 plus 35.4 times 2 plus 1 times 4, because there's 4 of them, plus 16 times 2, and your answer is 147 grams per mole. And the fourth example is calculate the molar mass of glucose, which is C6H12O6. So again, hit pause, try it on your own. Each one weighs 12, and there's 6 of them. Each hydrogen weighs 1 gram, and there's 12 of them. Each oxygen weighs 16 grams, and there are 6 of them. Therefore, your equation is 12 times 6 plus 1 times 12 plus 16 times 6, or 180 grams per mole. If you had a hard time with these after you're done with the video, go back and try them again. Molar mass is used to convert between moles and mass. You can determine how molar mass, grams per mole, which is what we just did back here, grams per mole, relates to the mass and the number of moles. Mass, grams, equals number of moles times gram per mole. If you have 2 moles of a substance and the molar mass is 30 grams per mole, then you have 60 grams of the substance. Okay? Again, you don't need to memorize the equation. Do what we were doing with the other video and write down what you start with. So if you started with 2 grams and you know that each one is 30 grams per mole, set it up so that your moles cancel. See how moles on the bottom of this fraction and on the top of that fraction, multiply it together, you get your answer of 60 grams. Also, the number of moles equals mass times grams divided by the quantity grams per mole. So if you have 180 grams of a substance, so write that down, whose molar mass is 18 grams per mole. Okay? Well, you can do it divided by this, or you can set it up as the fraction as I was doing the other day. Okay, so again we had 180 grams and the molar mass is 18 grams per mole. I want to know how many moles I have. So if we look at our whiteboard, I wrote down what we started with. We started with 180 grams. And I want my answer to be in moles. And the conversion that I know is that it's 18 grams per mole. Okay, what's going to go on the bottom of my second fraction? Is it going to be grams or moles? It has to be grams. Why? So that the grams will cancel. Okay? Specifically, how many grams on the bottom? Well, 18. And what goes on the top? 1 mole. So you put in your calculator 180 divided by 18. Your answer is 10 moles. It's a lot easier to just do the start with what you know and then put your next fraction so that your units cancel, and that will give you your final answer. All right, so let's look at some other examples. So, that was the one that we just did, as was that one. So again, they showed it to you here, even though they followed this equation. Personally, I think it's easier just to write it out and cross things out. Again, if you'd like some more help with that, just let me know. To convert from moles to mass, multiply by the molar mass. Determining the amount of a reactant or product is a key skill that is practiced in all fields of chemistry. Suppose you need 1.5 moles of ammonium chloride for a reaction. How many grams of ammonium chloride must you weigh out? Okay, so what are we starting with? Start with 1.5 moles, and what's the unit for our answer? Our unit is grams. So, step 1, we need to determine the molar mass of ammonium chloride. Okay, so it has one N. How many H's? 4. How many chlorines? 1. So 14 for the mass of the nitrogen plus 1.0079 times 4 for the mass of our hydrogen. And there's only one chlorine, so 35.453, which equals 53.5 grams per mole. Again, units are super important. Step 2. So we started out with our 1.5 moles. Then we know that there are 53.5 grams in every mole of NH4Cl. We put the moles on the bottom. Why? So they cancel. Multiply across the top. 1.5 times 53.5 grams gives you 80 grams. If you want 1.5 moles of NH4Cl, you must weigh out 80 grams for your reaction. Okay? Now, if you're thinking to yourself, well, they had the first step be to find this. How do I remember to do that? Well, I was reading this question. What I would do is I would set it up like this. I'd say, okay, I have 1.5 moles, and I'm going to multiply it by something. I know moles has to be on the bottom. And I want my answer in grams. Okay, well, if I want my answer in grams, that means my unit up here has to be in grams. Okay, so how do I convert from moles to grams? Oh yeah, to get grams, I look on my periodic table. So for every 1 mole, I added up the nitrogen plus the fact that there were 4 hydrogens plus the chlorine by looking at the periodic table. And that gave me 53.5. And now I can just do the math. So do you see how it wasn't about memorizing steps as much as it was write down what you know, cancel it off, make sure you end up with the unit that you want. It's kind of figuring it out instead of just memorizing an equation. To convert from mass to moles, continue to use conversion fractions. Throughout stoichiometry, conversion factors or fractions help in finding the answers to many amount-related questions. Okay, for a chemical reaction, you require 2 moles of sodium oxide. Your bottle contains 51 grams. Do you have enough? Okay, what are you starting with? And what do you want to end up with? You want to end up with moles, and you're starting with grams. Okay, so I would say, all right, I have 51 grams of Na2O, or sodium oxide. Okay, and I'm going to have to make a fraction, and I want my answer to be in moles. All right, what has to be on the bottom of my fraction? It has to be grams. Why? So that my grams will cancel. And what's going to be on the top of my fraction? Well, it's going to be moles because that's what I want my answer to be in. I want my answer to be in moles. Okay, so 1 mole is how many grams? Well, I want to look at my periodic table. And so when I do, each sodium is 22.99. All right, so sodium equals 22.99. And how many sodiums do I have? I have 2 of them. So I'm going to take that times 2 plus oxygen. Oxygen, when you look on the periodic table, is 15.99. Add that together, and you're going to get 62 grams per mole. So 62 grams per every 1 mole. So in your calculator, you're going to take 51 times 1. So 51 times 1 divided by 1 times 62. And your answer is going to be 0.82 moles. Okay, so look back up here. It said that you require 2 moles. Do you have enough? Obviously not, because you have less than 1 and you're supposed to have 2. And that's how you answer the question. How many molecules are in an 8-ounce glass of water? If the substance is a compound, then 1 mole expressed in grams is equal to the molar mass in AMU. For example, the molar mass of water is about 16 plus 1 plus 1. This 16 is from the oxygen. Where are these 2 1s from? The fact that there's 2 hydrogens in H2O added up, you get 18 AMU. So 1 mole of water has a molar mass of about 18 grams. All right, how many molecules are in an 8-ounce glass of water? So you have 8 ounces of water, and I don't know how you were supposed to know that 1 ounce was 30 grams, so I'm hoping they're going to give it to you. If it's something like that on a quiz, let me know. Hopefully I'll catch it ahead of time. But we changed ounces into grams. So basically we have 240 grams of water, and now we want to know how many molecules there are. So the first thing that we're going to do is we're going to go to moles. Why? So let's go back to our whiteboard. And we set up our problem. We have our 240 grams of water. Well, what has to be on the bottom of our next fraction? It has to be grams. Why? So it cancels. But I want my answer in molecules. Okay, moles are magic. Whenever you get stuck doing a chemistry problem, convert it to moles. It's like the magic answer to solve all your problems. Okay, so let's convert this to moles. So in 1 mole, how many grams of water are there? Well, each hydrogen weighs 1, and there's 2 of them. Each oxygen weighs 16. So a mole of water weighs 18 grams. Okay, our grams canceled off. Now we have moles. We're going to make another fraction. What has to be on the bottom of the next fraction? Moles. Why? So that they cancel. And 1 mole is the same as how many molecules? So I have molecules on the top, which, because the rest of my units cancel off, molecules is going to be the answer, the unit for the answer. And hopefully you remember that each mole has 6.022 times 10 to the 23rd molecules. So you put this in your calculator. 240 times 1 times 6.022 times 10 to the 23rd, then divide by everything on the bottom. So divide that answer by 18. When you do that, your answer is 8.01 times 10 to the 24th molecule. Put it in your calculator. Make sure you get that answer. If not, try again. If not, see me for help. So hit the pause button and read this. I'm out of time to read it to you. Honestly, it just takes practice. If you need help, I will help you.